Hello there. Today I'm going to be continuing to work on Kano script. Alright, so let's see. Basically, what we've got at the moment is we can compile things. We can have certain jumps. The jumps that do not work currently are functions, right? Because I handle them differently, so that's basically what I need to get working today is the function labels, function jumps, things like that. And then we should be able to compile this directly, right? Directly into the bytecode. Because before I was compiling it into the assembly for the bytecode, right? It's a custom assembly that I wrote, and that would get assembled into the bytecode. But right now, I just want to compile it directly to the bytecode, and then we can just run it there, or compile it, or whatever. That's sort of the plan, right? So I think what I need to do is get the position of the function in the that we're calling in the list of functions, and then we can do that. So let me see. Gen func call. So basically, what I want to do here is function label. So instead of this, I want to get the location of the function, right? So let's do we have any other get func? Is func arg is current func get variable location. Yeah, we really need the function location, like this this number, the I. So I think what I'll do is just yeah, I'll make a function for it. Sure. Get func location function name. Alright, so that's like the function name, right? So it's going to be quite similar to this, but if that, then we're going to return I. Right, and this is going to return a size type. So, right, there should not be, if we get to the end, we'll just assert false, because that should be checked in the parsing. Unexpected function. Alright, get the function. What is this? Okay, we don't need that. Let's see. Okay, close under that, and that should be good. So then, get func, right? We have gen func call. We want to get func location. That'll be what is that? And then we'll set it with the location, right? Okay, and we still append that there. And then let's see, in the func label, get this. We send it to that. Alright, that should be okay. Then when we iterate over this, case inst call, we want to functions data, and we want to use that, and we want to get the dot label of that. So break and break. Okay. Does not compile. Get func location. Yeah, so I need to get func location. I need to create the prototype for this because it is lower. So there we go. Yank it, and let's go here. And what do I have? Yeah, right here. Okay, and that should be good then. It does compile. Alright, and that did not work. That is interesting. Oh shoot, but that's in the assembly. Okay. Let me look at the rule 110. That's the wrong one. It's out 10. And okay, it still failed. So that's interesting though. It was a seg fault this time. Before, if I'm not mistaken, it was jumping out of bounds. I should have tested that. Let me remove some stuff here. .tim and .test. And clean it up a bit. Run it again. And we have out.tim. So what I want to do is do that, and I want to disassemble it. It's double dash. And then I want to put that into out.asm. And let's see. So jump. Call. Let's look at the call. Call at 32. So what is 32? 32 is a jump. Right. Go back into here. Gen label. Let's see, what am I doing here again? So we do that. So the labels data equals that. Function label. Alright, let's try something a bit simpler to test it out. So okay, no. This should work. This should work fine. Right, and then I'll work my way up. Like that's 15. But that is, so yeah, let's see, it should be 15. So then if I count so that 15. Alright, so that works. Now let's add a function in. So let's do main void and we'll just exit with x. No, we'll make a exit with z, and we'll call main on y. So it should exit with 15 again. So that still does, and then that does as well. Okay. And now let me change this to no, not 15, 55. Sure. And it does exit with 55. Alright, so that works. The function, okay, so it called the function properly. So it's somewhere else where it is getting broken, right? Okay. Let's add an if statement here. So if z is greater than 30, then exit with z. Else exit with z minus x. No, let's do it the other way. Z minus x, and then exit with z there, and end. Okay, so z minus x. Right, so if we pass to z minus y, and there we go. Yeah, okay, so let's try that. 40, and that is what's expected. That is also 40. Okay, and let's make it less than 0.9. And that works. Okay, that's interesting. So, 110. Okay, no. Look at this. So, could it be with arrays? Let's try some other stuff. Well, it shouldn't be really. No, let's do a different one. Int 32 equals. Let's do 0, right? Fill in 0. We can just do that anyway. And then, so we have 0 and exit with foo1 or foo2, and we'll set foo1 equals 200, foo2 equals 300. Yes, we do have to put a value in there. That's bit 44. That's not right. But that's not right at all. Hang on. It's less than that, so foo2. Something to do with this. No semicolon. 200. There, that's right. Okay. Wait, that's not even right. Hang on. Oh shoot, it's too large. That's the issue. Yeah, we cannot have a value that large. So 20 and I'm just stupid. Okay, so it wasn't an issue with that. Alright, 10, and that's right. So let's do that, and let's try to emulate out 10. 10. Alright, so that works. Okay. So something else. Let me run sh again. Let's do this, and we'll run it. Then I will emulate this and segfault. Alright, so let's look at maybe where it's segfaulting, you know? DDB. Click on run instructions. Run. Yes. Oh shoot. Okay, run with out.10. Okay. Yeah. So let's go through here. So set up those. Okay. This got very messed up for some reason. It does not look right. Switch over that. So let's see where it actually fails, you know? Let's run through it. I press continue then. Okay. So it's in there in mem move. Alright, so I don't know where I would call that from. So I think I can do that. Let's see, 619. Let's look at that. See, it's not here. Well, it is. Mem copy. Alright, so in the int right. Okay, so we have an invalid pointer. That's gotta be what it is. Or the size. It could be the size as well. So let's break on 619. Anyway, break on name.c. 619. Alright, and run again. Continue. No. Okay. Try that. No, it's 10.c. 6.8. Alright, now we'll run this. And we'll continue. Okay, so right here, so let's print the size.word.as. That is 8. Print pointer. Print pointer. What is it? It's probably gonna be a char star, right? Nothing. And that is not where it failed. Okay, so that was not it. So let's continue to the next one then. Print size.word.as. Print char. PR? No. Okay, print. Yeah. Print. Actually, I need to dereference that. 0, so I don't think that's it. Float? I don't think I use any floats. I don't know what else it would be. That's not even where it failed. Okay. Continuing. Print size.word.as. It's 1. Oh shoot, cannot access memory address. Okay. So it's like 4 or something. Ooh, okay. And that's where it failed. Alright. So we are somewhere there. So that was the one of the rights. That's not great. Alright, so let's disassemble this again. Just this. Into out.pass. So let's look at the right calls. So we have one here. So that one is fine. That is writing that. That one is fine. Who's the third one though? Alright, so we jump over this one, so go to 100. We go here and right. So is it this one? Push 0. It's really hard to tell where that's gonna be at. But if I modify this this one, and I go to push that, and I make that correct, and I assemble this. I do that. That one works. So what I'd like to do is disassemble this one now. And let me actually remove add some to make sure. This, that, into adding, and look at that. Actually, now I will recompile that. And alright, so that's the word. So we know that this is valid. We don't know if that's so. We just need to basically compare these. Can I do diff? Out. Cat. Okay, so there's not very many diffs. So 2VP. Alright, so let me see. I can quit out of this one. And alright, so let me exit this one because I want to use 3. So Kano switch source. Not source. let's open out Chasm here. And then here, we can look at the diff. So I'll open one. Actually, I could make a split screen. I forgot about that. Build, and then look at rule 110. Alright, so that's what we're looking at. These are two separate ones. Then inside this, and I can look at the diffs. So 57. Let's see, 57G is 0 jump, 87. Okay. Alright, so that's 107. So that is not right. So that one is wrong. So it's a 0 jump. That is wrong. Alright. The next one, so it's all 0 jump. Okay, no, there is another jump that is different. So this is 78. I guess you can see it pretty clearly here. 34 and 100. Okay, so the jumps seem to not be right. Alec is a 2VP there. That is interesting. So let me look at that. 162. Is that supposed to be Alec? What is that? Why would that be generated? Because we have other Alecs. Yeah. I change this to an Alec. That is very weird that it would be that. And there's another one at 217. Alright, let me try that. No, it still doesn't work. Okay, but that's interesting. So I don't know why that's being generated. Let's get with the jumps though. Because those are incorrect, right? Incorrect. Shoot, no, I lost that one, my bad. Okay, so we have this. Alright, let's take a look at the jump. So gen jump, right? It's just the jumps that are wrong. Well, no, it's the labels, because we're getting the labels from it. As in equals labels, so let's go to the gen jump. Func deck label. Alright, that's gonna be the index, right? So all of them, over all of them. We set it to the labels data from that. So if we gen label, go to that, then we do that. Machine instructions count. Maybe I could look at the machine instructions count. Machine instructions dot count. Instructions dot count. And let's do that. Whoops. Okay, and let's go here. So I will save that. 78, 87. That's all the labels that we generate. That actually looks like right. I will get out Chasm and build 110 Chasm. And now there's a lot more. Wait, what the heck? Oh yeah, because it's gonna be way different now. So I need to first disassemble it. So because that gets rid of the labels or the comments and stuff that I generate. Chasm. Okay, and now we can look at it here. And the other thing that is just running it. Oops, that's wrong. Okay, and whoops. Right. It's kind of hard to go up here. Let's generate the div again. Chasm and Chasm. Div. And that's the wrong one again. I thought I did that. Because I generated it again. Okay, I am stupid. Let's do that. And let's do that. And then div. Div actually. And then do that. Okay. So we have this. And then I will. Oh, okay, split screen again. And the other thing I wanted to run was, yeah, let's run. Yeah, okay. I want to compare that. No. No, okay. Okay, so 78. We don't have 78 there. 87. So 87 is wrong. Right, so this one. Which one has the 87? And what, which one is that one? 80, no, what? Right, 57. That one has 107, which is incorrect. Okay. But there is 87 here. There is no 107, though. So that is... Ooh. Okay. So we must be generating them properly, because 78, we then have that. But this one's 164 for some reason. We don't have 164. So it's getting garbage data? Is that what it is? But it's consistent, so I don't know what that is. 34. I don't have any 34, though. 34 is 87. Let's have a 34. That's 100. We do have 100, though, so that's interesting. What else? 152 or 53. We do have 152. We don't have 453, so... And then this one. Alright, so we're not setting it properly, it seems. So is this not working? Then instructions count. We set it to that. Let me print out state labels data instructions data dot value data. So let's take a look at that perhaps. Here. No, okay, no. And that's a lot of stuff actually. So maybe I'll print it with a space instead. And let's try that. So they'll be on all the same line. I just want to be able to see them all at once, right? So we go there after. So 100. 107. Yeah, so 107. Something's being set to 100. That's right there. Yeah, okay. 107. But it should be 87. Yeah, so why is it 107? What is that about? Oh, shoot, because we have other labels. Oh, shoot, I didn't even think about that. Because we have gen wall label, and that's probably what it is. Okay, I forgot to consider that. So let's add this pencil in here. And I think it's the only other label that we have. So, let me try it again. And that's not what I wanted to do. It's the wrong one. Okay, now we have the 107. So that's where it's coming from. Shoot. Okay. Give me 1 second. I'm going to be right back. Just about 3 minutes. Just give me a second. Okay, so it looks like what the issue is to me is probably the wall loops. So to test that, I want to gen wall jump, and I want to print. I can't really do it here, can I? But that's where it's wrong. I'm quite sure. Let's get rid of this. And we'll just print out the wall ones. The wall ones. And 34. 34 is, wait, that's the right one. 107. That's the wrong one. 164. That is the wrong one. 453. Yeah, so it looks like we have an issue with the wall labels. And I did not test the wall labels. That's something I didn't test. So we can test that up really quick. If I make Kano, and I just use a wall loop. So wall z greater than 30, z equals z minus 1. And then we'll exit with z, and that's probably going to create an issue, right? So let's go 35, 30, 35. And I'll just get rid of this, don't need that stuff, and let's try that. And without an open block, I think I forgot a then. Okay, so we do that, and then, no, 10. And yeah, it failed. So I'm pretty sure that's what it is. Okay, so gen wall label, and I think I know why. Gen wall label. Put that here, but we don't pass it the same. It's not handled the same way, right? So we suddenly need a separate one for it. Because we need to call with wall labels in different places. But we do have the list of state wall labels that we can use there, don't we? Right, so we decrement it there. So if we use that, shoot, but we don't know when it's a wall label. But shoot, if we use the index in the wall labels, but we need to set it afterward, and we don't know how to do that. Like, shoot. Let me see. Okay, that gen wall jump. So this is something we need to change. What do we call it? Gen wall jump. We call that on a type n. If we're in there. And that's it. Okay. So, okay. So we already know what it is. So if when we gen the wall label. Right. Gen wall label. We use this as the indexing. To what? Wall labels. Can we do that? It shouldn't be though, but we can do that anyway. It wall labels equals that. And we set that. Okay, let me try that, and then gen wall jump. We can just set it equal to the label, and we don't have to iterate over it again though. So shoot, but how do we make it so we don't want to do that? What else do we create a jump? What else do we jump for? Gen wall jump and gen jump. We gen jump anywhere. We do for the functions and the alright, so right, that makes it a bit harder because we don't want to change it. So and there's not really extra data we can add here. Right. Yeah, it makes it very difficult when we're handling everything differently, but we kind of have to do that, right? Because of the nature of each thing, the functions, the wall loops, and things like that. So let me think for a moment, because I need to know. Right. Equals label. Alright, so what about right, if we give it a type of a void type, right? This is sort of a marker. Then, not a void type, but it's a pointer type. We give it that as the marker, then we can know not to modify it, right? Okay, so if state, not state, but instructions, value dot data type equals pointer type, then continue. Alright, let's try that. Just to make sure, so let me exit out of here. Let's see. Register type? It's type pointer, right? Well, no, because it's int type, so is it ptr type? Yeah, okay, that's what it is. 1.6 ptr type. Right, this is just a temporary way to do it because I have to revise the entire list because it's very messed up. Word has no member name data type. Okay, 738. So it's not word, it is just dot data type. Okay, let's try that. And it gets stuck. Alright, because I do something here. I get this stuck. Spinning stuff out. That looks like it would. Rule 110, okay. Why does it get stuck? That is interesting. And break. And then we just go to the end here. Otherwise we set it to that. Is it breaking in here, right? Is this what it is? Let me see. No, okay, so it's somewhere else. Where else are we breaking? Like that. Like that. That is not an F like that. Yeah. Alright, tabs don't really work here today. Print that. Okay, right here. So gen wall rate. So this gets broken. It's probably because of this. Let me get rid of that. Actually, add a boundary check, but then it doesn't break. Out. In. And that is not right. Okay. Nice. So this, let me just assert that, label. Oh, shoot, I see who this here. I need to append to, state wall labels. Let me try that, right? Whoops, let me see. Okay. Still doesn't work. Shoot. Let's do, rule 110 in disassembly. And I'll just put this into correct TASM, right? And then if correct TASM and out TASM, but we need to actually do this, and then look at out TASM, and then we can look at the if correct TASM and out TASM. And alright, jump 34. Okay. We did not change the type, that's what it is. We need to change the type from the pointer type. That might not be the whole thing, but it's at least part of it. So we want to set instructions data I data type equal to int type, and then break. Okay. Alright, so we disassemble it, but let's try to run it. And I did not mean to do that. Yeah, so it still does that. So let's try that again. And let's look at it out TASM and correct TASM. And there's a lot of stuff here. What? Out TASM. Try to see it. Whoops. Okay, so I used the wrong thing on the slide. now we'll look at it. Okay, so it's with these. Alright. So that is, okay. So we're getting close. So why are we generating void programs? And this is, instead of an Alex, so gen Alex. Create inst Alex. So we have that. 2VP. We do create that. This is probably supposed to be a gen Alex, isn't it? Is it? No, because we write a 2VP here. Do we do that anywhere else? That's 2VP. VP as well. This one is supposed to be Alex. Okay. Right. I just messed that up. And we do that now. Run it. And then emulate it. Rule 110. Not rule 110, but outside thing. There we go. Okay. It works, yes. Alright, so there was a number of problems having to do with wall labels, function labels, and that last thing, the built-in thing. It was just typo, right? But we do have it working now, so hopefully it is working. I should write a couple more complicated programs to test to make sure before I remove the assembly generation entirely. I'm very happy about that, though. So I'm going to commit that, and then that's going to be at the end of the video. Let's see, fix all issues with wall labels, function labels, as well as an issue with one via built-ins. And we'll push that. And it wasn't even that much, I guess. Yeah. So, okay. Because now, this allows us, we could run it. So, say we're running, Kano script, right? And you run it on a midnight Kano. Then we could emulate it directly, or we could have, run or compile, right? Something like that. I think it could be pretty cool. But yeah, that's going to be for next time. So, thank you guys for watching, and I'll see you next time. Bye.